Okay, so we're going to do problems number 3 and 4. Our first problem we see is cosine squared of 3x, and we want to use the power reducing formula because that's what the directions say. The directions say reduce the powers. So we're just going to go ahead and use our 1 plus cosine 2 theta, and in this case, theta is 3x, so we just copy 3x in. This can be multiplied out. 2 times 3 is 6x, so it's cosine of 6x all over 2. And that's it, we're done. Let's go to the next problem. It's again to the 4th power this time, so the trick to this one is squaring it, separating our exponents. So it's cosine squared 2x to the 2nd power. We know the identity for cosine squared is already given on top. We're going to copy that into our problem instead. And it's no longer squared inside. It's just 2 times 2x. Copying our theta in. And we have to multiply it out. So if you remember, we talked in class about squaring a binomial. So we're going to multiply 1 plus cosine 4x by itself twice. And that becomes square the front, square the back, and double the middle. And we're going to double our middle term, which is 1 cosine. So it becomes 4 cosine. No, sorry, 2 cosine. And we squared the back. Now we have a square of the cosine squared now. We're going to have to power reduce that. So you go ahead and substitute that with, again, our identity. And our identity on top is 1 plus cosine 2 theta. But our theta now is 4x. So we rewrite that as 1 plus 2 cosine of 4x plus 1 plus cosine theta over 2. But the theta is now 4x, so 2 times 2 is going to be 8. So we're going to write that in just a little bit. Now the goal here, as you can see, there's a fraction over fraction. So we're going to write a common denominator over the whole top section of a 2. So the 1 gets a 2. The 2 cosine 4x gets a 2. So that's what we wrote, 2 plus 4 cosine 4x. And our common denominator now is a 2, so we can just write 1 plus cosine of 8x all over 2, all over 4. Now since we have a fraction over fraction, we can multiply by the reciprocal. So we're going to do that right now, rewrite everything, and that 4 over 1 becomes a 1 over 4. And then we're done. For our next problem, we have our identity, cosine of a plus b. So how do we get 285? It's not a special right triangle for us. So we're going to combine two angles that we do know. And the identity is in your notes, and I'm writing it on the board right now. Which is, remember, cosine is cosine, cosine, sine, sine. So we're plugging in our a and b value. So we're going to use 240 and 45. Again, you can use any angle of combinations that you can to make up 285. It just, we have to know these angles. So cosine of 240, cosine of 45, minus the sine of 240, and then the sine of 45. Now we're going to go ahead and draw our two triangles. 240, which is in quadrant 3. Our sides are going to be, since it's a 60-degree triangle, 1, 2 square root of 3. Don't forget the negative signs. We'll come back and, I forgot that. And then a 45-degree triangle is 1, 1 square root of 2. And we're just going to, I always fill out the parentheses, and then we can fill out our fractions. Okay, the cosine of 240 is negative 1 over 2. The cosine of 45 is, we write it as 1 over square root of 2 as square root of 2 over 2. And the sine of 240 is negative square root of 3 over 2. And again, the sine of 45 is square root of 2 over 2. We're going to write a common denominator here since they both have a 4 at the denominator. And negative times square root of 2 is negative square root of 2, and negative negative is a positive, so that's the square root of 6 on the back. And we're done.